In session 64 here, we're going to be starting factoring with algebraic expressions for the next 8 lessons or so. But before we start factoring algebraic expressions, it's helpful to go back over factoring that you've already done up until this point. First, let's do a quick review of what prime numbers and composite numbers are. A prime number is an integer that's greater than 1 whose only two factors are itself and 1. So for example, the number 3. What are the only two factors for 3? Well, 3 and 1. Number 7. What are the only two factors for 7? Well, itself, 7 and 1. The number 11 is also prime. What are its only two factors? Itself, 11 and 1. So a prime number is a number whose only two factors are the number itself and the number 1. A composite number, on the other hand, is an integer greater than 1 who does have factors other than 1 in itself. But its factors do include 1 in itself. For example, the number 10. 10 and 1 are two factors of 10, but you also have 5 and 2. Therefore, 10 is a composite number. The number 100 has many different factors. You have not only 101, 100 times 1, but you also have 50 times 2, 25 times 4, 10 times 10. So those are some examples of composite numbers. Now then, let's do a review of breaking a number down into its prime factors. And what I'm going to do is I'm going to use a method that many of you are familiar with to determine the prime factors for a particular number. I'm going to use the tree method. A little hierarchy, kind of a tree, is how it's illustrated. And what I want to do is I want to take a look at the number 420 and I want to select one prime factor that I know for it right off the bat. And then I'll rewrite this number as a product of that number times some other type of number. And then we will continue on down to the point at which we are only left with prime numbers. So oftentimes it's helpful sometimes to start with the smallest composite number, or excuse me, smallest prime number that you can divide into a particular number. Well, what is the smallest prime number? Greater than 1? Well, the smallest prime number is the number 2. And if you remember your divisibility rule for 2's, that rule says that if you have any number, whatever that last digit is that's in the ones place, if it's a 0, 2, 4, 6, or 8, that number is divisible by 2. Well, since 0 is the last digit in 420, that tells us that this number is in fact divisible by 2. So I'm going to break this down into a product of 2 times 210. 420 is the same thing as 2 times 210. Well, over here, our 2 is a prime number, so there's no other way to break this down any lower. So we're going to leave this 2 alone. But 210 is still a composite number. It is not a prime number yet, so we need to break it down further into primes. Well, once again, it also ends with a 0, so that tells us it's divisible by 2. Well, 2 times what is 210? Well, half of 210 is 105. So 2 times 105 is 210. Well, once again, our 2 here is prime, so we are done with that portion of it, but we're still left with the composite number over here of 105. Our 105 ends with a 5, therefore it's not divisible by 2. Next thing you can do is take a look at your next smallest prime number. Your next smallest prime number after 2 is 3. And if you remember, your divisibility rule for 3's says take all the digits in your number and add them together. Well, 1 plus 0 is 1, plus 5 is 6. Is 6 divisible by 3? Yes. Since the sum of the digits is divisible by 3, so is the whole number. So we know 105 is divisible by 3. So what we need to do then is to rewrite that as a product. 3 times 35 is 105. Our 3 is now prime, so there's nothing more for us to do there, but 35 is still composite. So we need to break it down into smaller numbers. Well, 3 plus 5 is 8. 8 is not divisible by 3, therefore 35 is not divisible by 3. Well, 35 is not divisible by 2 because it ends with a 5. Well, our next smallest prime number is the number 5. And your divisibility rules for 5 says that if a number ends with a 5 or a 0, it's divisible by 5. Well, since 35 ends with the 5, that tells us that this number is divisible by 5. 5 times 7 is 35. Is 5 prime? Yes, it is. So there's no other way for us to break it down any smaller. It's already a prime. Is 7 a prime? Yes, it is. Its only two factors are itself, the number 7, and 1. So there's no way to break it down anymore. 3's prime, 2's prime, 2's prime here. So we can see now that the number 420 broken down into prime numbers is going to be 2, 2, 3, 5, and 7, all multiplied together. So I'm just going to rewrite this over here in order from smallest to biggest. 2, that takes care of that, times this 2, times 3, that takes care of that one, times 5, times 7, and that takes care of those as well. 420, therefore, as prime factors is 2 times 2 times 3 times 5 times 7. And just a quick double check, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, 60 times 7 is 420. So we just double checked to see in fact that this is the correct answer. Now then, let's go ahead and take a look at the greatest common factor, and that's what GCF is an abbreviation for, greatest common factor. This also is a review, but once again, this will help you in factoring algebraic expressions. So let's do this the way that you probably have in earlier years in your math classes. Just start at the beginning. We know what are two factors of 24 off the bat. Well, we always know that the number 1 and then the number itself. So 1 times 24 are two factors. We know 1 is, so let's take a look at the next one, 2. Is 2 a factor? Yeah. 2 times 12 is 24. What about the number 3? Well, 3 times 8 is 24. Well, what about the number 4? Well, 4 times 6 is 24. And that's it. 1, 24, 2, 12, 3, 8, 4, and 6 are 8 factors, or are the 8 factors of 24. Let's take a look at the number 72. Well, we know 1 times 72, so that's 2 factors. We know 2 is divisible because this ends with a 2, so that would be 2 times 36. Using our divisibility rule here, 7 plus 2 is 9. 9 is divisible by 3, therefore 72 is also divisible by 3. 3 times 24 is 72. What about the number 4? Well, 4 times 18 is 72. What about the number 5? Well, 5 doesn't work because this doesn't end with a 0 or 5. The number 6 does work. 6 times 12 is 72. 7 doesn't work, but 8 does. That gives us 8 times 9, equaling 72. So then, there are all the factors of 72. 1, 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Let's go ahead and start underlining common factors. Well, 1 is a common factor, but 1 is a common factor for every integer that there is. So oftentimes we just do not even treat it as a unique common factor. We're interested in common factors greater than 1. So I'm not going to underline 1, even though it really is technically a common factor. Let's take a look at our next number greater than 1 that's a factor. That's a 2. Well, is the 2 also a factor down here? Yeah, it is. So 2 is a common factor. Let's take a look at our next biggest one, 3. Well, 3 is a factor up there, and it's also a factor down here. 4 is a factor up here as well as down here. 6 is the next biggest number. That's also a common factor to both of these numbers. 8 is a common factor to both numbers. 12 is also a common factor to both numbers. And lastly, 24 is a common factor to both numbers. Now the question is, out of all of these common factors, which is the greatest? Well, 24 is the greatest. So the greatest common factor between 24 and 72 is the number 24. Now then, let's take this just one step further. Let's go ahead and separate that here. What if we had the numbers 15 and 28? What is the greatest common factor of 15 and 28? Well, let's start off here. You have 1 times 15. What else? What are the other two factors that you can multiply together to give you 15? Well, that would be 3 and 5. So 15 has 4 factors: 1, 15, 3, and 5. And what about the number 28? Well, obviously you can always have the number 1 as a factor, so we'll start off with that. 1 times 28. 2 times 14 works. 3 is not a factor, but 4 is a factor. 4 times 7. And that's it. So the number 28 has 6 factors. The number 15 has 4. Once again, let's start looking for common factors that are greater than 1. Well, 1 are common here, but once again, we're looking for the ones, the common factors that are greater than 1. Let's take a look here. The next greatest factor is a 3. Is a 3 a factor down here? No. What about 5? Is 5 a factor down here? No. And then lastly here, 15. Does it exist down here? No. So technically, what is the only common factor that these two have? 1, the number 1. When you have two numbers whose only common factor is 1, those two numbers are called relatively prime to each other. And that's just a term that you'll use a little bit more later here. Lastly then, quickly as a review, a prime number is an integer that's greater than 1 whose only two factors are 1 in itself. A composite number is an integer that's greater than 1 that has factors other than 1 in itself. And then lastly, relatively prime, two numbers whose only common factor is 1 are relatively prime to each other. That'll finish up then session 64 on the prime and composite numbers.